Thumbs up if you're ready to rock and roll today. You have everything open and available. All right. Very good. So we're going to get started. So what are we going to talk about today? Well, we're continuing our discussion. And if you would, make sure those notes are available. We talked about last class period, what a method is, right? Contains one or more lines of code that will execute to perform a task when it is accessed or called. And the dot operator is definitely used to do that, right? That's how a method is called or accessed, using the dot operator. We looked at several examples. Now, I want you all to be mindful that when I say methods, the methods that we've been familiar that we've used and we've used early in the semester, we've used them all semester long. We've learned about them over each lesson. The methods that we've used thus far were predefined methods, those methods that were already created for us by those who have managed the Java language. So Oracle has these suite of defined classes that contain methods and properties. And if you notice here, again, all of our methods that we've seen before, remember the method name always follows the dot, the access operator. So the method here is called next. The method here is called squirt. The method is called println. Here's the method called substring. Here's the method called equals. Here's the method called char at. Again, these are all methods, right? Methods. And I didn't really, some of these I did not complete properly. May do some of those, yeah. Let me just update these a little bit, just so you know what we're talking about, right? If I say the substring of, right, the substring of at 3 or something of that nature, you can just kind of see what I mean by that, right? Again, why did I add those things in the parameter? Because I want you to be mindful of the following, is that the method, we always go to the documentation to look at what that method needs. This is very important as we begin to learn how to write our own methods. The name of this method that I have highlighted is char at. We've used it before. In the documentation, when you go to the documentation online that Oracle provides, it tells you that if you use this char at method that belongs to the string class, you must provide it a number, right? We've got to provide it a number, a whole number. That's considered the index, right? And so in order to use the equals, right, we have to provide it a string, some string inside of the parameter. In order to use the substring, right, you have to provide it a number. And which substring you call depends on which substring is executed, depends on how many values in the substring you provide. So if I say start at 3 and end at 8 in the parameter, so these two are, remember we learned that there are two, there's more than one method that belongs to the string class that's called substring. Right, one method needs one value, one integer passed in the parameter. Another substring method needs 2 integers passed in the parameter, where this is your starting index and this is the ending index minus 1. I hope that none of this, the things that I'm saying right now should not be, you should not go over your head, right? You definitely be foreign. You should appreciate that there is more than one substring method, right? We've talked about that when we introduced the string class and its methods. Why am I reviewing that? Is because, again, we've got to get used to going to when we look at methods, we need to look at them a little. We're going to start looking at them a little differently, especially as we write our own methods. Like, what is needed in the parameter? So when that method is called, this is an example, and I'll put this right here. These are examples of calling a method. Okay, we call a method by its name and you provide it the values in the parameter. So what if I say something like 50, 50, 30, right? Something like that. So in order to use the max method, you must give it 2 integers, right? And so again, each method, right, we need to know what it needs. And so in the past, with predefined methods, we had to look at the documentation to figure out what we needed to provide that method in order for that to use that method properly. But when we're writing our own, we've got to specify that in the function definition, which is what we're going to learn about how to write today. So last class period, these are some of the things we talked about, right? Some examples of some methods that we've already looked at. We also talked about that in the past, we've written all of our code in the main method. That's an important Java method. That method always executes first. So we're not going to eliminate the main method. We need the main method because the main method is going to drive everything else in our program. And so remember that it's analogous to a relay race. The main method has the baton first, and that baton is then passed off to other methods as those other methods are called. And control returns back to whoever called that method. And the examples that we're going to be looking at, main is going to be mostly who's good, but I do want you to appreciate that any method can call another method, not just the main method. Any other method that's in your class can call another method. And so be mindful of that. What else do we use? Why in the world? You're going to learn about as you read in lesson 7, why in the world we use methods, right? Reusable code, right? That reduces redundancy. I spelled it wrong there. Redundancy. And we can call that method anytime we want, an unlimited number of times. If you need to call that method to perform that task or action, we can call that method over and over and over again without having to include all of the steps that are the one or more lines of code that are inside of the body of that method. We don't have to write those statements over and over again. We can simply call our method. All right, so with that being said, right, what are user-defined methods? These are methods that we define, that we write to perform some task or action, right? And so it contains those one or more lines of code, just like what any method does, but we define what these methods do. So we need to, in order to use a method, we've got to do the following. We've got to declare the method, right? Which defines what that method will do once it's called. And then we've got to call that method. That method will not execute. That method declaration will not execute unless we call that method and tell that method to execute, right? And then, and so that's where we left off. That's where we left off during our last discussion. So very good. So let's keep rocking and rolling. And so what in the world do we want to, what are we going to discuss next? We're going to discuss here the syntax of declaring. So I told you how important, in order to write our user-defined methods, we've got to declare declare a method, right? Our user-defined method. And so here's the syntax. So we'll just say declare a user-defined method. Okay, that's what we want to talk about, how that's done. So we're going to look at the syntax first. And we're going to go over that syntax, and then we're definitely going to look at some examples on how to do that. So be prepared to write some code. Be prepared to write some code. And so the syntax looks like the following. What goes out in front is our modifier. So this is how we can declare now let me say this, just like I put up here in our notes, let me bring this down here. So when I say declare, we're declaring a function or a definition, right? So here, what are we doing? Think about it like the following. So this is what when you hear me say function or method, declaration or definition, okay, they are all interchangeable. I can say function declaration or function definition or method declaration or method definition. These mean the same thing. I want you all to appreciate that. So right now we're learning the syntax for a function declaration or definition or a method declaration or definition. That's what we're learning right now, is the syntax for doing this. Okay, so how does it, what does it begin with? It begins with a modifier. Now, we'll talk about what some of these things are optional. What does the modifier mean right now? Let's just look at let's just go over the syntax first, and I'm going to explain each item in our syntax, right? Each element in the syntax for your method declaration. All right, so modifier goes out in front. The return type, it always follows that. And then what always follows the return type is the method name. What always follows the method name are open and close parentheses, and then open and close curly brace. What's inside of the parentheses is what we call our formal parameter. I'm emphasizing this on purpose because you may hear this again. So this what is inside of the definition or the declaration, the function definition or declaration, this inside of the parameter list, this is the formal parameter list. Formal parameter list. We'll talk about why I call it formal in just a second, and what's the difference in formal and informal, or whatever the case is. So we'll talk about that in just a second. So what goes inside here, of course, or goes inside those open and close brackets is what we call, of course, the body, right? The body of the method or function. Absolutely. So that's what's inside. So this is our function declaration or definition. Now let's spell this out a little bit. Let me describe these elements. So what do we mean by the following? What do we mean by the function, the modifier? Let's say that. The modifier. So what is the modifier? The modifier defines how the method must be accessed. That's what we mean by the modifier. And so some examples of that would be public or private. Okay. So we can emphasize that a method, and we can even say or static, right? Or static, etc. There are some other modifiers that are out there. So this is what we call a modifier, whether we define it as a public or private or static. We can go on and on. So a method can, if a method is not public, then it's considered private, or we can also define it as static. But modifiers are how the method is accessed, who can access that method. So you're going to learn about that in your reading as well. Public, who tells your computer that, hey, computer, any class, whether any class outside can access this method that's considered public. Private simply means that that the only class that can access this method is this class itself. Static means, right, we've talked about the difference in static methods versus instance methods, right? So if we use that keyword static, that tells the computer who can access this method, right? That it's either the class itself can access this method, or if that's static, or an instance of this class must access this method. So we know that if you use the word static, that tells you that the class itself must access this method. Or think about methods like the math class. If we look at the documentation for the math class, we'll notice that max is a static method, which means the class has to access this method, has to tell this method to execute. If you look at the documentation for the next method that you see here, the next method, you'll notice in the documentation that the keyword static is not associated with this method. So this method must be an instance method, which means that the class cannot access this method. An instance of that class must access this method. So this is the object, right? Objects are instances. So the object or the instance must access this method called next, because the documentation says so. It's not a static method. So if it's not a static method, as we learned about in lesson 6 and 5, in lesson 5, that if it's not a static method, it must be an instance method, which means the instance or the object must access this method. Again, we're just tying all these things together, but that is what we call our modifier. So when we look at documentation, predefined documentation, we also have to pay attention to what its modifier is. because that tells us who must access this method in order for this method to execute. The next thing that you notice in the syntax is that we have a return type. Right, so what in the world is that return type? This defines, excuse me, the type of data that will return once the method successfully executes. That is key, right? And so once it's so here, if you see here an example, we're going to learn about different the various return types that exist. Okay, so a method, examples of return types, or methods could be the following. It could be we could have a void method, right? A void would be a method, a type of return. If it's void, that means nothing is returned from this method. That's what that means. Or it could be a value returning method, a value returning method, which examples of that would be things like int, float, string, etc. Any of the data types. So I again, what are some examples? So when we say return type, what is the return type of that method? There are only two types, return types that are valid. It's either a void method, right? A void method, which we're going to learn about. We're going to look at that example of that today. Or, and let me do it in this manner. Maybe this will help. So one is a void method, or the other type of method return values that we can return are what we consider to be value returning methods, right? So void methods or value returning methods. Those are the only two types of returns that we are valid for when we define a method. A void method, if we define, that's the return type that we define for a method, then that means nothing is returned from this method once it executes. No value is returned. So we can specify that a method is void, and we're going to look at examples of that, or we can determine that a method is value returning, which means that that method can return some data type, like an int or float or string or double or char, whatever the case may be. So return type is specified next. So the modifier, the return type of that method, and what always follows the return type is the name of the method. And here, method name. And method name here, that defines the what? This defines the name of the method, and it is case sensitive. It is case sensitive. And so what I want you to appreciate about the name of the method, Java recommends, and we've talked about this, whether you, I want to make sure that you recall that when we define names for identifiers for variables, as well as user-defined methods, then the names that we give them, they have certain, Java recommends certain things. So for instance, like for constant variables, right, that we name those in all caps, that's a recommendation. Another recommendation that Java makes with respect to naming things is method names, user-defined methods, method names. Java recommends that we always start our methods, right, using lowercase letter. So Java recommends that user-defined methods start with a lowercase letter. Okay? The lowercase letter. And so be mindful of that, which is why we've, have demonstrated those things as well. But if you notice here, the predefined methods that Java has written for us, they all begin with a lowercase letter. These are predefined methods that Java has already written for us, and they all begin with a lowercase letter, okay? All right, and so they recommend that for even the methods that we define ourselves. And so then what about, let's do this. So what about the next thing, which is your formal parameter? So your formal parameter list. Why do we, first of all, why do we call it a formal parameter, right? Right. So first of all, I want to make sure that we know that this is optional. It depends on how you write your function. So you may write a function that does not need you to pass it a value, that method is just going to do something on its own. It does not need any values passed to it in the parameter list, which means it's optional. You may write a method that requires you to pass it certain values before it can do what it needs to do, perform the action or the task that you need it to do. And so here you'll see, what do we mean by the parameter list? So the parameter list lists each value that is needed by the function or method to perform some task. Task or action. Okay, so that is what the method needs in order for it to perform its task or actions. We want you to be mindful when we say formal. So why in the world is it formal, right? And I do need to make sure that you notice that let's say here first before we talk about why it's formal, each value or each variable has, what did I say here? Why am I doing this today? Path must be separated by a comma. These are things I would have written on the board, actually, if we were, in face-to-face class. But these are the things that you need to be mindful, right? Is that in our parameter list, each of our variables must be separated by a comma. Why do we consider this to be the formal parameter? So why is this a formal parameter? Because we're going to look at an informal parameter or argument in just a second. So why is it considered to be a formal parameter list? Why is that? Well, it is considered to be a formal parameter because we have to specify the data type for each variable or value passed in the parameter list. Okay, so you have to specify the data type. So this is where in the formal parameter list is always associated with, and I'll put list here, it's always associated with your function definition or function declaration. It is not associated with the call statement. Yes. So for example, requiring 2 ints to do a fancy multiplication method. Absolutely. High five, Anthony. Very good. Absolutely. So the parameter list you required would be 2 integers. Absolutely. So int A, comma, int B, you need to give it 2 integers in order for it to do what it needs to do. Okay. That's the formal parameter list. Okay, so when we talk about call, we'll talk about what it looks like for our call statement. But for the function definition, this is what it's for. So let's move on. Now let's talk about what do we know about the other statements that you see here. So the body, of course, the body of the method. We know what that is. That represents, right? That represents those one or more lines of code to execute, to perform a task, to perform tasks. I'll say that task in parentheses, so there may be one or more tasks or actions. When the method is called. And that's very important. When the method is called, it will not perform those tasks or actions unless the method is called. Okay, but that's the body, that's the important thing to remember about a method. Okay. Any questions or concerns so far? Is this making sense? Yes. Thumbs up if this, you understand what we've done so far. We're gonna use this in some examples right now. Questions, concerns, we get it so far? All right, if there are none, then we're gonna write a few simple examples, right, first. And then we're gonna come back and I'm gonna talk about the function call statements in just a second, but let's write a simple example. A few examples, because I want to drive home. Before we leave out of here today, I want you to be clear about how to write a function definition, what that looks like. And that's our goal today. And we're gonna write a simple program where we're using our own user-defined methods. So let's click on our source and create a new class. Let's call it the sum of nums. Sum of nums. Okay, sum of nums. Right with me on that? So that's the name of our method, of our class. Do you notice our class name is capitalized, but our methods and variable names are lowercase? Let's go here and write our main method. We need to always include that main method. So our main and then tab. And let's go ahead and comment our closing curly braces. It's going to be so important that you comment your closing curly braces now, because our programs are going to be much more complex. So this is the end of the main method. And this is the end of our class. Please do this, please, because what we're going to be working on is writing methods outside of main. Now, I want you to follow a few things with me here, okay? So what I want us to do, I'm going to demonstrate to you in this example how a simple program is, how we write a program where we have user-defined methods to do certain things. Remember from this lesson, from the previous lessons, all of our code was written inside of main. Well, now we're going to be writing our code outside of the main method, but inside of the class. Now, where you put this code, let me emphasize this, does not matter. You can put the code after the main method, or I could put the code before the main method. It matters not. Why does it not matter? Because as I mentioned in our notes, when this program compiles and runs and executes, what is the computer going to do? It's going to search for immediately inside of the sum of nums class. It's going to search for the method called main first. It doesn't care the code before it or after it. It's looking for the method called main. It's looking for the method that's called main. Doesn't matter where you put it inside of the class. It could be at the end or the beginning or in the middle. It matters not. This is the method that will always execute first in a Java program. And so that means that if you want any methods that you have outside of the Java of the main method, if you want any of these methods to execute, then the main method must start the race. The main method must pass the baton at least to the first method outside of the method outside of main. And that method can pass it off to whomever it wants. Maybe it passes control to another method or whatever. But the point is that who always has the baton first in this relay race? The main method does. Right? And so let's go ahead and write our function. We're going to write this function definition. And now here's what I want us to do. I want us to write this function. So here we're going to write a function. So we're going to do the following things. We're going to define what this function is going to do. So here's our function definition. Everyone should write these things, these comments. Then we're going to talk about what the purpose is of this function that we're writing, and it's outside of the main method. We're going to talk about the return type for this method. What is going to be the return type? I like writing these things for every one of my user-defined methods. What is the parameter list? And then what, and so those are at least the things that I like for this method, okay? Just describe that I want to describe for my function definition, okay? So what do we see here? So what is this method? This method that I want us to write a method called sum of numbers, okay? That needs two things, that needs two integers. So if I call this method, the purpose of this method that I'm going to be writing, that's called sum of numbers. And you see that it starts with a lowercase letter. This is a method, a user-defined method called sum of numbers. And if you want to, you can write here, here's a user, this is an example. User-defined method or function. Okay, this is an example of a user-defined method or function. So here, what is the purpose of this method? The purpose of this method, given two integers, it will calculate the sum. What did I say there? Calculate the sum and print the sum. Calculate the sum and print, let's say, and print the results. So I want you to appreciate, though, that I could write this program many ways and get the same output. Let me just pause here. So when we write user-defined functions or methods, you can, again, you're an artist. You're the programmer, you're an artist. And not, this is your interpretation. So I could rewrite this method and rewrite this program several ways, and still get the same, given a set of inputs, still get the same outputs. You will never know. So again, this is your masterpiece, but this is only one example. I'm giving you one example of how this could be done. So I could write this function other ways, but I've decided to write this function. Given these two integers, I'm going to allow this function to, given those two integers, calculate the sum and print the sum. I could require another method to print the sum, but we'll look and see how that's done going forward. But again, there's more than one way to solve this problem. So let's go ahead and write our function. I'm sorry, what's going to be returned from this method? This method is going to be a void method. I'm writing it. Could I write this as a value returning method? I sure could. But for this example, I'm going to make this method void. This method is going to not return anything. It's just when this method is called, it's going to do several things. It's going to calculate those two values you pass to this method, and it's going to also print. So it's going to do these two things. It will calculate the sum, and it's going to print. So it has these two tasks. Now, could I separate what we call modularize our program? This is what we call modularizing the program. We're making we're not putting all of our code inside of a main. We're creating these user-defined functions who have specific tasks to do. These user-defined functions will have specific smaller tasks to do, so that main does not have to do all of the heavy lifting. Main can just simply call these outside methods, and these methods will perform these simple specified tasks and return those values, or return potentially do those tasks or return the results back to main, so that main can do whatever it needs to do with them. So it's all about how you write it. So the parameter list, what is needed in our parameter list? If you're going to use this method, you've got to provide it to integers. That's just how I've written this method. Could I have written this method other ways? Absolutely. Okay, so now with that being said, this is an example of how we would write this method, an example. So the modifier always goes out in front. So remember, modifiers we could define are public, right? I would want most of the methods that you're going to be writing this semester and these last few weeks is going to be public. not so much private. In lesson 8, you will be exposed to what private methods do and how private methods are written. Yes, but in this case, most of the methods that we're going to be writing, user-defined methods, are going to be public, so that any method outside can access it. It is optional. You don't have to specify that public or private here, but I like defining what that is. We definitely have to, though, specify whether we want it to be static or not. I would want all of the methods that you're going to be writing, or that we write, are going to be considered static. Why? Because we don't want to have to create a new instance of an object of this, to create a new instance of the class to create an object and have that object access this particular method. No, we want the class called sum of nums to have direct access to this method, so it's considered to be a static method. So most of the methods that we're going to be writing, user-defined methods, are going to be static. All right, so what always follows the modifier? So public and static, that's our modifier. What always follows next, according to my the syntax that I've discussed, what follows next? Put in the chat for me really quickly. What follows the modifier? What do I need to state next in my function declaration? What's next? What's after the modifier? In the syntax, what follows the modifier? No, in the syntax, that's an example, but in general, what follows what follows in general? The return type. Return type. Does everybody remember in our notes? What always follows the modifier is the return type, right? Does that make sense, everybody? That's what should follow. What did I tell you that I wanted this method to return for this example? Again, can you write this method other ways? Sure, you could. I'm showing you this approach just as an example, okay? I don't want this particular method that I'm writing. I will show you how to write this method as a value returning method going forward. But right now, let's just learn about void methods, okay? And so I said I wanted this method to be void. That's going to be its return type. So that means that this method, once it's called and it successfully executes, it does not give anything back to the returning method. I mean, the calling method, the method who called this method. Does not give a value back. It just gives control back, gives the baton back. Okay. So with that being said, what always follows the return type in the syntax? What's next? What's next after return type, everyone? The name, the method name. And so I told you that the name of this method is called sum of numbers, right? Sum of numbers. Then what always follows the name of the method is an open and close parameter, parentheses, and then open and close curly brace. So let's go ahead and specify that. And then we know this is going to be the end of sum of nums, end of sum of numbers. Okay. Do we at least have this, everybody? So this is what we have. Now we've got to define our formal parameter list, And so remember our formal parameter list, our formal list, remember it must include the data types. All right, the data types. And so here, what do we know? I told you that that this method needs 2 integers in order for it to perform its task. And so I could call this anything I want. I could call this maybe num1, it matters not, comma, int num2, it matters not. But what I want you to appreciate is you've got to declare these two variables. These variables, their values are going to be passed to this method, okay, and assigned. So they're going to be initialized, but that's what the values are going to be assigned to these variables that I'm declaring here during runtime. So during runtime, during the execution of this program, num1 is going to get a value and num2 is going to get a value. And that's the value that's going to be passed to this method. Okay, we'll demonstrate what that looks like. Does everybody hear what I mean by that? This is an example of a formal parameter. list that you see highlighted. Formal parameter lists are, please put this in your notes somewhere because I promise I'm going to ask this again. Formal parameter lists are always associated with a function definition or a function declaration, right? Always. It's not associated with the call statement. It's only, it's a formal parameter list is associated with the function definition or method definition or declaration, okay? Because we have to spell it out. Now then, what's going to go inside this function? Inside of this function, I want us to do the following. We're going to need some variables. So think like we did in main. Now, think of this method as if we were inside of main. What will we need to do in order to add two values together? I'm going to need some declare some local, declare a variable. Well, what we call this is a local variable. Any variable that we define, and this is what you're going to learn about inside of lesson 7. Lesson 7 is going to talk about global variables versus local variables, what we call the scope of a variable. And we'll talk more about that another day. But here, what I want you to appreciate is whenever you declare a variable inside of an open and closed parentheses, that variable is only known inside of that block of code. So for instance, any variable that I need right now. So for instance, I want to define a variable here that's going to store, right, temporarily store the value that from where I add num1 and num2 together. This is going to restore store the result. So I'm going to temporarily temporarily store the result of adding the two ints together. Now, why did I say temporarily? Because I want you to appreciate this, and again, we're going to learn about this in later discussions, but this variable called sum, you notice that I'm declaring it inside of this user-defined method. This variable called sum will only exist as long as this method is executing. When this method stops executing, all local variables or variables that I declare inside of this method are going to be thrown away and eliminated from memory. They're going to be thrown in the trash. They no longer exist. So this variable that you see that I have highlighted, it only exists and is known about inside of this function. Outside of this function, it is not known. This is why this is why we call it a local variable. It's local to this block of code. Thumbs up if that makes sense to you. And again, I'll demonstrate this going forward, I promise. But any questions about what I mean with respect to it being local? Now's your time to start asking questions. You please don't sit there and have questions and be timid and not ask. Do you have any questions about what I've stated? I only see River. River, you understand everybody else is lost? Because I asked for some kind of confirmation. I can't see your faces. I have to gauge some way that you're there and that you're understanding what I'm saying. All right. Devin, do you get it? Joy, I didn't see your finger up. Do you have questions, Devin? Or Joy? Joy, you got it? Okay. All right. All right. So with that being said, what else am I going to do inside of this function? So now that I have this variable called sum that's going to store the results, here I want to calculate. Remember the purpose of this particular method is to calculate the sum and to print the sum. So just like we did in main, nothing complex here. I will say sum equals num1 plus num2. Why am I don't see any you don't see any values, but we will be passing values to this method. And what values that we will receive? We're going to receive a value for num1. We're going to receive a value from num2 during runtime, and those are the values that we're going to take the sum of and store it into this local variable called sum. And what is the next row? So that's one of the rows, is calculate the sum. That's one of the role or task of this particular user-defined method. What's the second responsibility of this method? Is to print the result. right? So we can some system.out print ln. What am I printing here? The sum is, I'm going to say this, the sum of, and just we're going to concatenate of num1 space and outside I'm going to concatenate that with num2, concatenate that with space is colon, and then the value of the result that's stored in the variable called sum. I'm going to pause here to see if you got that. What do I want to print? The sum of whatever the value that was passed to num1 and whatever the value that's stored in num2 temporarily is whatever the result is of that's stored in sum. Do be mindful that all of these the variables that are mentioned inside of this method called sum of numbers are going to be erased from memory after this method called sum of numbers executes. So the sum, num1's value, num2's value, all of these variables are going to be erased and their values erased from memory, because this is, and so so there's nothing that's going to leave this function. Why? How do I know that? We see that this method is a void. Its data type is a void, which means that once this method executes, it does not give anything back to the calling method. It does not return anything. That's what void means. On Thursday's class, we're going to look at value returning methods, while I'll demonstrate to you how to rewrite this and how to write a method that returns a value. This is an example of a method that does not return anything. So does everybody see how this method works and looks? Try to do the following. Go ahead and run this program, please. Run it. Run the code, and hopefully you've completed the code. Run the code, and you see that there's nothing being displayed. Why? Can someone tell me why really quickly? Why? Why in the world is this? Are we not this? We don't see any output? Why? I'll wait for you. Why is there no output? Any ideas? Any ideas? Whether they're right or wrong? Shall I call on you all? What do you think? Nothing's happening in main to call the function. Absolutely, right? We've not called this function. That's the key. Please put this down. I mean, if you don't already have it, and we have it in our notes, because I went here and I said the following. I said that it will not be right here. A function or method will not execute unless it is called. Do you see that in our notes? So that's what I want you to be mindful of, that a method will not execute unless the method is called by and told to execute. That is so key. Okay. Give me just a second. I apologize. I'm answering a student's question. Direct message. All right. So with that being said, and I hope that makes sense, the response that I've given you here, one of the students. Okay. So with that being said, let's take a look at our code again. And now let's go up to main. Finally, we're going to go up to main. Now, what are we going to do inside of main? We are going to actually call this method. And so let's now go update our notes. We're going to go to the third thing here. And I want us to write the following. So we're going to learn we're going to learn how to write a method or function definition, function call statement. So a method or function call statement. Right, and we recall that a method will not execute unless it is called. We need to be reminded of that. Here's the syntax for calling a method. What do? Out front, we have the name of the method. And then what always follows that is the open and close parentheses, right? Open and close parentheses. And then what's inside is the what we call the actual parameter list, or informal. We call it the actual parameter list or the informal parameter list. That's what always follows. So here, what do I mean by actual? So in this case, it would be case of sum. It's the numbers you want summed. Yes. Yes. Absolutely. And so here, what do we mean by the actual? Here's what I want you to appreciate before I move any further. What do we mean by an actual parameter list? It simply means this. It's associated with the call statement. It does not, here's what I want you to remember. It does not include data types. Okay, it does not include data types. That's why we call it the actual. I'm going to say actual or informal. You may also hear it as called that as well, or informal parameter list. That means the same thing. Okay, informal parameter list or actual parameter list. The informal or actual parameter list is always associated with the call statement, not a function declaration. So let's look at what that would look like. Your call statement is where you're going to pass the baton. Like, remember I talked to you all about it being a relay, similar to a relay race. Well, here is where we're going to call, let's go ahead and call the function right here inside of the main method. I'm inside of my main method. How do we call this function? We call it by its name. You have to call it by its name and tell it to execute. The name of this method is called sum of nums, right? So let's say here, call statement for sum of numbers, right? That's the name of the method. All right, and what would that look like? So we've got to simply call this function sum of numbers, and this function needs, and look how, and this is the beauty of working in an integrated development environment. You notice that as I'm inside the open and close parentheses, the computer, this integrated development environment tells me that I need to give it 2 integers. I didn't know that because I've already defined right here. I've already defined or declared my function definition. So it knows that this is a function call statement. And so it's looking, in order for you not to get an error, it's looking that you either you need to give it 2 literal integers, or you need to give it variables who have values that are integers. So here I'm going to give it, let's say we do the following. I'm going to give it 30, 45, something of that nature. Do you see that? Those are the 2 values that I'm passing to this method. Do this for me, please. After my call statement, I'm going to, let's go ahead and let's print statement outside. I'm sorry. Let's print this statement after. We'll say after the call statement. I want this simply be just a simple print statement here, just to prove to you how this works. I'm going to say back inside of the main method. Don't forget your semicolon. So what is this going to do? Before we push the run button, let's follow how this works. As soon as I execute this, as soon as the computer executes this program, it's going to look for the method called main, which it found it, and it goes and it executes from the start to the finish. So what does it notice? The first line of code that it will execute inside of main is it realizes there is a call statement. A call statement. It's going to search for a method called sum of numbers, so that it's going to leave this method and pass control, or the baton, pass control to the method that has the name sum of numbers that needs 2 integers. That's very key, because this call statement, there's a call statement that, we supplied it 2 whole numbers, 2 integers. So it's going to search for, in this class, it's going to search for the method called sum of numbers that needs two whole numbers, that needs two integers. It found it. And what is it going to do then? It's then going to execute that, the body of its function. So what are we doing? We're declaring a local temporary variable called sum. We're calculating the values, and here's the key. The value, so when this method executes, what's going to happen? That the value 30 is going to be bound to the variable num1, and the value 45 is going to be bound to the variable called num2. Those values are then going to be passed into this function, so this function can do what it needs to do with those two values. So we call this pass by value. Passing these values, these literal values, to these local variables, because this is num1 and num2 are considered local variables. So in this method, we have three local variables defined: num1, num2, and sum. Those are the variables that are going to be destroyed and erased from memory once this method finishes executing or ends its execution. Right? So here, once those values, so here, what am I doing? Adding 30 to 45, right? Getting the result of that. And then I'm printing this inside of this method. And then once I print this statement, the baton or control is given back to the main method, where it picks up where it left off and executes the next line of code that it sees after the call statement. So let's see what that, push the run button so that we can see how this works. And you'll see the sum of 30 and 45 is 75. Where did this take place? This took place inside of when the method called sum of numbers executed. This took place. We calculated the sum and we printed. This print statement demonstrates control being given back to main, the baton given back to main, so that now main has control. And this is an example of how a void method works. Thumbs up if you were able to follow this example. All right. Any questions about this example? Questions or concerns about this example? All right, if there are none, give me just a second, because I do have just a second. I do have a class reflection, and it is going to be due here in just a second. Give me just a second here. I just needed to update that really quickly. Sorry for that. And sorry. All right. So with that being said, you should now see the class reflection, and I'm going to I don't know why I did it. Is it not posting? You should see it. If you refresh, you should be able to see the class reflection for today. I'll post it also in the chat there. But if there are no questions or concerns for me, let's get out of here. What are we going to talk about on Thursday's class? We're going to talk about how to